For this particular unit, we are going to be working with radical functions. And to start the unit, we're going to talk about the root value of the radical function. And this is going to bring back some principles that you learned back in the quadratics unit. If you look back, and this is probably a good thing to review, if you go back, you can remember back in the quadratics unit, we worked with square roots and radicals, and we learned what the radical sign was and what the rules were for simplifying radicals. So all of these rules that we learned for simplifying radicals will still apply as we go into this radical function unit. So if you need a little refresher, it's probably a good idea to go back to the quadratics unit and pull up that pre-lesson worth of notes. And this is something that you learned in Algebra 1, so should be familiar at this point in time. Now, the difference in this particular unit and what we're going to be working on here is that we can have a root value that is greater than 2. So just like we can have a power greater than 2, we need a root to offset that power. And so you can see here in this little picture that we show you the given parts. Now, what sometimes you'll find is your teacher will refer to the index as the root value. And what you'll probably recall from square roots is that the root value actually offsets the power. So if we had x squared and we wanted to eliminate the power of 2, we took the square root, thus having the root and the power eliminate each other, leaving us just x. And so we use that to help us solve quadratic equations that had squares, and we use a square root symbol. So what we'll need to do is we'll need to learn how to simplify radicals that have a root value that is higher than 2. And so you'll also remember that when we had square root equations and we took the square root of the value, it created a plus or minus symbol. So we'll also need to discuss how that will come into play with various root functions. And so if we look at this, you'll need to learn all the different parts involved with radicals. Now we have two major issues here. If the value for n, in this case, what we're talking about is the root, so you can see the little index there is n. If it's an odd number, there's going to only be one root, and it's going to be the positive value is going to be the principal root. So that is pretty straightforward. So you can see if we had the cube root of a number, such as the cube root of 8, we're just going to end up with a positive 2. And if you think about it, if we had the cube root of 8, such as we have in this example, that's going to equal a positive 2 because a positive 2 to the third power equals 8. If we did negative 2 to the third power, it would equal a negative 8. So that would not be what we're looking for from there. So if we have an odd root there, if the index is an odd number, you can simply take the positive root. However, with even power roots like square roots and fourth root and sixth roots and so on, you're going to have both a positive and a negative value root, and so that's where the plus or minus symbol will come into play. So keep that in mind, that an even root will create a plus or minus symbol for both the positive and negative root. Now, if the b value is negative, that's when we get into imaginary numbers. So if you remember, the square root of a negative 4 would be 2i, because the negative root was imaginary. So we won't focus on imaginary numbers in this particular unit. So just keep in mind that it's a non-real number. So let's take a look at a couple examples of where we could use roots with higher degrees. And so if you look at example number 1, this whole premise of what we did before to use square roots, we now want to use with a higher degree root. We want to isolate the term that's being raised to a power. So if you look at both of these examples, we needed to isolate the term that was being raised to a power before we could take the root value. So what we did in part A is we actually took the fourth root of both sides so that we could eliminate that fourth power. And the same thing in part B. We have isolated the entire parentheses that's being raised to the third power, so we're going to take the third root to isolate and eliminate that power. Alright, and so that's just a starting example, so hopefully you've worked sample problem number 1. If not, go ahead and do that at this time, and I'll go through part A and B with you. Okay, so the first thing that we need to do is we need to isolate the term that's being raised to a power. So the first thing I need to do is, just like if this were 6x equaled 3,750, we want to get the x by itself. We do the same thing by dividing both sides by 6, leaving us x to the fourth equals 625. And we want to get x by itself, so we are going to take the fourth root of both sides, and we would put that little 4 in the index, and we would have to do that to both sides. Now that's going to cancel out the root and the power, leaving us just x. Now, at this point, you probably don't know the fourth root of 625, and hopefully you will start to learn some of these more common roots and powers higher than a square root. So at this point, you could probably just simply use your calculator. So if I go to my calculator, I can use the root function, and if you look over here to the left side of the 4, you can see they have an n with a radical and an x. So we're going to use that function, and it's going to give us two boxes with a template here. So I'm going to put a fourth root in that box, and then 625, and I'm going to hit enter, and that's a value of 5. So x is equal to 5 in this case. Now, the next thing that we need to be concerned with is this. Were we dealing with an even or odd root? And in this case, it was an even root of 4, so that means we would go back up here, and that's where our n value is even, our root value is even, so it's going to be a plus or minus 5. So our final answer would be x equals plus or minus 5. Alright, let's take a look at B. In B, I already have the term that's being raised to a power isolated. So here I'm just going to go ahead and take the cubed root of both sides. That's going to eliminate the power, so I'm going to be left with x plus 1 equals the cubed root of 18. Now, if you don't know your cubed roots, you could check this on your calculator, and you would see that the cubed root of 8, take that out of there, and the cubed root of 18 gives us some crazy fraction. In this case, my calculator is giving it to me as rational exponent. So it's not an even, clean number, so we're just going to leave it as the cubed root of 18, since there's no perfect third power in there. So now we just need to move over the 1 and get the x by itself. Now, I prefer to see this written in front of the radical. This keeps it from being confusing if you accidentally extended your radical too far. And there is only a positive root here because we're dealing with an odd index, and so this would be your final answer. Okay, so that's a good start to learning about radical expressions and simplifying radicals. We'll continue in the next set of videos to look further at examples.